To close that, or can you see it?
It's okay.
Maybe we close it? Yeah. Yeah, I think that's good. Thank you. Okay. Let's get a start here. Solve and sketch cubic. Okay. So let's get a start here. So this lesson really continues on a lot from the remainder theorem and long division, and there's not really a lot to do this morning, so we'll get straight in with an example anyway. Let's have a look. Let's do a couple of examples here. We'll do let's see, we'll do S first. Let's have a look at that. So y equals 24x cubed minus 5x squared minus 68x minus 36. And what I'm looking to do here is to sketch it, which also means to solve it, because I need to figure out where it crosses the x and the y axis. Okay. Now, there is a small problem because I don't give you any hint. I don't tell you one of the factors. But I know some of you mentioned this last time, that if you don't actually have a factor, you can try to find one. And the way to try and find a factor is you try to find a root. And the way you find a root is you need to try and guess an x that could make this 0. You need to try and guess it for an x here. Now, there's some values of x that you shouldn't even bother trying. So there's no point in trying to see if 0 works, because if you put in a 0, you'll get 0, 0, 0 minus 36, which obviously is not 0. So you might be thinking, okay, could I try a 1? So I'm not even going to bother to try 1, because I can tell 1 won't work, because what will happen is you'll get 24 minus 5, okay, well that's getting closer to 0, minus 68 minus 36, so that's going to go way past 0. So it's definitely not going to be 0 and 1. Could it be minus 1? Well, if it's minus 1, what will happen is these two guys will become positive. They'll both be positive. So what's that? That's going to be, around about 80, 90 mark. And this one here will be like around about minus 40 mark. So obviously minus 1 isn't going to work. So I know 0, 1 and minus 1 isn't going to work. But maybe 2 or minus 2 could work. So this is maybe where I'll start. So I'm going to start with 2. Let's see. Let's start with x equals 2. So 24, 2 cubed, minus 5, 2 squared, minus 68 times 5, minus 36. What will that equal? Alright, sweet. Okay, so my first guess was right. Is it? Huh? Oh, sorry, here? Sorry. Should have been. I don't know why this jumped to 5 all of a sudden. 4 and 2. And it is 0 though, with the right numbers put in, yeah? Now, nobody's expecting you to guess correctly the first time. You may have to try a few numbers before you find the one that makes 0. Okay, but at least be a little bit smart about it. Don't try something which is obviously not going to work. Like obviously, 0 could never work here. So don't even bother trying with 0. So in the exam, what I recommend is if you really don't know, well, the good news is in the exam, the answer will be always one of the following numbers. They'll always make the root one of these numbers. So you'll never have to go outside of this to find an answer in the exam. They confine it to this. Great, so we now have figured out that x equals 2 is a root. So that means x minus 2 is the factor. Now, why do I know that? Well, from the remainder theorem. Because if I put 2 into this, I get an answer of 0. And the remainder theorem tells me that that is what the remainder is. So I know the remainder is 0. But if I know the remainder is 0, then I know it's a factor. So I'm 100% confident that this is a factor. There's no doubt about it. So because it's a factor, I can now divide it in. Okay. That, and that. Okay, so the first one, what's that going to be? 24, isn't it? 24x squared. There's 24x cubed. Minus 48 x squared. And then, what's that? 40... Minus 5 minus 48. Is that 43? 43x squared. Is this right?
Yeah.
Are you sure? Okay. Plus 43x. So that's 43x squared minus 48x. Like that. What's that now? Minus 20, isn't it?
Yeah.
No, but this isn't working out then. So I'm not getting 0 at the end. Are we sure this adds up to 0? Somebody confirmed that?
No.
24.
24 times 2 is 48.
Yeah, 48 there. This one? The 48x. Oh, it's supposed to be 43. Thank you. Hang on, I know what the problem is. I need more coffee. Alright, do I need to redo the last line? Yeah, okay, let's try that again. Okay. Let me just go back to here. Thank you. Minus 68x minus 36. Alright, everything okay to here?
Yep.
Oh, I'll bring it over in a second. Everything's okay to here, yeah? Alright, so the next one has to be 43x, true? So this will be 43x squared minus 86.
Yes.
There we go. Alright, so I subtract, what have I got here? 86 minus 68, isn't it? So what's that? 18? 18 plus 18, is it?
Yeah.
So, 18? Okay. That's better. So that's 18x minus 36, which is the 0 then. Okay. What should I do next now? I'm trying to figure out all the factors.
Solve the quadratic.
Yeah, solve the quadratic. I wonder now, can we easily get the factors here? Okay, so this is what I'm thinking. 24 could be 6 and 4. 18 could be 9 and 2. Let's see, 6 and 4, 9 and 2. Is that going to work? 36
No.
and 12. That's not that?
8 and 3.
Did you use the factorizing program on your calculator? Thank you. What are the factors?
8x plus 9.
8x plus 9.
3x plus
3x plus 2. Wonderful. So I have 1, 2, 3 factors. So what are the 3 roots? The roots are at 2, minus 9 over 8, and minus 2 over 3. Okay? And there's the roots. And where does it intersect the y-axis? The y-axis at what point? Minus 36. Okay? So you have 1, 2, 3, 4 points for your cubic. So you can easily draw it. I need to scroll down a little bit here. I'll just squish it in here for you. Right, so it crosses at minus 36. So I'll just mark minus 36 here. It has 2 negative roots and 1 positive root. So, like here, problem?
How do you get minus 36?
I put x is 0 in the original to find out where it crosses the y-axis. It is minus 36, isn't it? Yeah. Did I show you what the shape of a cubic was last time? I don't think I did I? So cubics look like this. They either go up, down, up if they're positive, or down, up, down if they're negative. And so which one is it here? Well, if we go back, it's a positive, isn't it?
Up, down.
So up, down, up. What's it? Up, up, down, down, left, right, A, B, A, B.
That's
Canonical code, isn't it? Alright, so let's see. I need to pass here, 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 and here. Oh, that's going to be ugly. Ooh. There. Right. Sorry, there now. 1, 2, 3 roots, and there. Obviously mark the numbers off on your graph in the exam. I'm getting a bit squished for space here. I'll do another one, of course. We'll do a couple more. If you can write this one down. So this one here has 3 roots. Could you imagine this graph cutting the x-axis only twice? How would I change this graph so it cuts the x-axis only twice? What could I do to it?
Well, all the vertices have all these.
Yeah, one of the vertex, yeah, it has the value at the root. So, could you imagine if I just lowered this graph a little bit, so that this point comes down and touches the x-axis? So it looks like that. Then it only has 2. Don't worry, I'll do an example like that. Okay. So, can I scroll down? No, you're writing. Like this? Can you still read it? Okay. Actually, let's do it here too. Someone over here needs it. Have we got this? We got this? Yeah. Can you read it back to me? What was it? 24x cubed
plus 43x
plus 43x
plus 18.
plus 18x minus 36?
No, I thought you wanted the quadratic. Never mind.
Oh, give me the cubic, please.
Yeah, then 24x cubed.
Yeah.
Minus 5x squared.
Yeah.
Minus 68x.
Minus 68x.
Minus 36.
I just want to show you what it properly looks like. If I just switch it here. Now, it's actually, you can't. Huh? Why isn't it showing up? Let me. Oh, there we go. Now it actually looks like it has only 2 roots, one here and one here. But if you zoom in, I don't know if I can zoom in. Can I zoom in? Enlarge. Oh, I have to pay to enlarge it. Can you see here? It actually has 2. Oh, hang on. Wait, I know. I'm not paying for anything. Right. Can people make that out? There's one here and one here. So there actually is 3, and this one here, can you see, is about minus 36. Okay. So let's have a look at another one now. Can I scroll down? Do you have this? Yeah. Right. Okay, let's think about this. So, should I bother with 0? No. Should I bother with 1? Possibly. I feel like 1 might work. Guys, listen. I feel like 1 might work, because if I look here, if I use 1, I'll get 49 and 81, which is, you know, like 130 or whatever, and minus 77 and minus 45 will be about the same size. So I think 1 is worth trying. So let's start with, it's not 1? Okay, well, if this was like a real exam question, I would have tried 1 and it wouldn't have worked. So what happens if you try 1? You get 8. So you get a remainder of 8. So that's no good. We want a remainder of 0. Okay, so if 1 doesn't work, I don't feel like minus 1 would necessarily work, because, well, actually, let's see. I get 49 and 45, so that's about 100, and 81 and a minus 77. No, that couldn't be. So it's going to have to be a 2 or a minus 2. I could try 2. What would I get? I don't think minus 1 would work, would it? Did you try it? It is minus 1. Okay. What was it when it was 2? Not 0 anyway, that's for sure, yeah? What is it? 75, alright. But you're saying when I use minus 1 I do get 0? Okay, remainder 0 then. So therefore, x plus 1 is a factor. So let's divide it in. Cubed, squared, x, 81. Right, what's the first one here? 49, isn't it? 49x cubed plus 49x squared. When I subtract, what do I get here? Minus 77 minus 49. Minus 126, is it? Is it minus 126? Yeah. Minus 126x squared minus 45x plus 8. Is it not? Come on, you guys have calculators. Tell me what it is. Is it minus 126 or not?
Yes.
Okay. Minus 45x plus 81. Minus 126x, yes? Minus 126x squared minus 126x. I subtract and I get 81x plus 81. So the last one is 81. So I have 81x plus 81 equals 0. Okay? What are the factors here? Let's see. Right, I think 49, maybe it's a 7 and a 7 and a 9 and a 9. Would it be that? I think it's that. It's a 7x minus 9. 7x minus 9. It is that? Yeah.
9 times 7 is 9 times 7 is 1.6.
Yeah, it seems like that, doesn't it? Okay, so this one's quite interesting because these guys are the same. So it means the roots, right here, the roots are 9 over 7 and minus 1. And the y-intercept, y-int, 81, isn't it? So there's one, there's the other one, and there, what do we say, 81, wasn't it? Now, what do you do when this happens? Well, is it a positive or a negative cubic?
Positive.
It's positive, and it goes up, down, up, but it only has 2 roots. So what happened here was, it goes up, down, and then as soon as it hits this point, it must immediately go back up. Why? Well, what would happen if it didn't? If it continued true, then there should be another root. So it can't be doing this. So it's up, down, immediately turn, and that's it there. So there's 2 roots only. Okay. We'll do a couple more. We'll do 2 more examples. You can write this one down. My experience is there's usually one graph per exam. Maximum is 2, but usually if it's 2 it'd be like one plot and one sketch. Finished? Everybody has it? Okie dokie. Thank you. Can I scroll down, guys? Do you have this? Yeah? Okay. Another one now. Minus. Okay, let's have a look. Right. It could be 1. No, it couldn't. Could it? No, it couldn't. It's not 1. I can see it's not 1 because that's like 18 minus. But, yeah. It's not 0. Could it be minus 1? Let's see. That's a 7 and a 4. 7, it's 11. No, it's not minus 1. So it's not 0, 1 or minus 1. So maybe it could be 2 or minus 2. It's a plus 2, is it? If you try x equals 2, you get the remainder then is 0. So therefore, x minus 2 is a factor. Okay, so let's divide x minus 2 in. Minus 7x cubed plus 12x squared minus 4x plus 16 minus 7x squared, so that's minus 7x cubed plus 14x squared, yeah, looks okay, doesn't it? Minus 2x squared minus 4x plus 16 minus 2x, so that's minus 2x squared plus 4x minus 8x plus 16, so the last one has to be minus 8. So I get 8 minus 8? No, plus 8. I get 8 minus 8x. What? I was right the first time. Yeah, sorry. Minus 8. Minus 8 plus 16, yeah. 0. Okay. Now, if we try to factorize this, we'll fail. Because this one has no factors. Yeah. Because it has no roots. Because the discriminant, if you calculate it, it's 49 minus 4ac, so minus 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 56. So the discriminant is negative. So it has no more factors. It only had the 1. So it has one factor. So x equals 2. That's the only root, yeah. And what's the y-intercept?
16.
Y at 16. Okay. So how on earth will that graph look? Let's try. 2 and 16. Now, just be careful. It's this one is a negative, so it's down, up, down. Yeah. Now, we actually have a bit of a problem. We don't quite have enough points to draw this properly, because, you know, if you think about it, there's actually a few ways I could draw this. You know, I could go... not just yet, though, but we could, yeah. So we could, like, for example, go down, up, down, here. Or maybe it's down, up, down. Now, there's actually... There's many possibilities. So, I think the appropriate thing to do here at the moment is you should try and figure out what the y is at other values. So you should perhaps put in what do you get if y is 1, what do you get if it's minus 1, and what do you get if it's minus 2. So if I was to put 1 into this, what would I get? Minus 7 plus 12, yeah? Is that 5? 5 minus 4 is 1. 17. So it's a little bit higher at 1. Okay. Can somebody... Oh no, I know what it's doing at 2. It has to be here at 2, here and here. Okay. What's it doing at -1? Is it higher or lower than 16? Can someone... Let's see, -1. So that's 7 plus 12 is 19. No, what am I saying? Sorry. -1. Yeah, sorry. 7 plus 12 is 19. 19 plus 4, 23, and 16. It's quite large, isn't it? So it's going to be like up here. So -2 must be really large. So I think what's happening is it makes the turn here on the right. It's going to come flying down and then do a little flip at 1 and then continue on down to 2. Okay, let's see. Let's see.
I can give you the table if you want for each one.
Now I'm just looking at the graph here. Question? Yeah? Sorry, say again?
Can I continue the question I have on the graph?
Huh?
I have a question on the graph.
What about it?
So, why did you assume that the 2 would be the last point that you have? Why didn't it be down and then down under the x-axis?
Oh, the turn.
Yeah.
You mean like this point?
No, the other one.
This one?
The 2.
This one, yeah.
Yeah.
I know. Yes. What are you asking about the 2 exactly?
So why didn't it be that it went down under the x-axis, went up and then went back down? You would have also one intersection, wouldn't you?
Okay, describe it to me. So where should I start?
Can I come with you?
Go show me. Yeah, come up and show me. While you're showing me that, I want to show the class what the graph properly looks like. Now, this graph is a bit zoomed in, so what you can't quite see is that, can you see here, it actually continues up on the left of the y-axis? But you see how it does go up at 1 like we thought, and then comes crashing down to 2. Yeah.
Oops, sorry.
What are you thinking here?
So why couldn't it have gone, let's say for example,
Mm-hmm.
down and went back down under the x-axis?
It could have. It could have.
Because you assumed that it's the last point.
Yeah,
this
no,
point
it could have,
is
it could have. This is possible, The reason I know it's probably not this, and I checked here on the graph, is because when I put in the value of 1, it was a little bit higher than the y-intercept. This was a 17. So I know it's beginning to do its turny bit here at around about the 1 mark, because it's going back up after coming down from a large number. You know? So like, for you, let's see, it goes down, crosses at 2, yeah. So what would happen in yours is, if you were to put in a value of 3 and 4, you would see it go down, go up a little bit again, and then go back down. Yeah, and you would have to do that if, suppose instead of getting 17, I got something here like 15. Then it'd be quite clear that what's happening is what you suggested. That's hitting through the 3 points. Yeah, so that's a possibility to consider. I didn't need to consider it because I figured it out on this one. But if it didn't work for me here, I'd have to start thinking more about this. Yeah. Good. Okay.
The thing is before you even got 17, you were like, this is the last point, so I got.
Oh no, there's you could imagine many more ways to draw it. Yeah. And in fact, in some situations, it doesn't even have a turn. It just looks more like a straight line.
The thing is that this seems so much like a sine graph, you know what I'm saying?
It is like a sine graph, yeah. Yeah. I mean, if you continue, I have one more example to do.
Anyways, thank you.
No problem. Okay. There's one more example I want to do. Okay. Guys, look up. There's one more example I want to do, and it's when you have something like this. When is the cubic greater than or equal to 0?
One has two distinct roots.
No, you're thinking of with the quadratics here. No, that's true though. But I suppose my question is, we want to solve this. Figure out what x's make it positive. So in other words, you can think of this as actually just a graph problem. If you had the graph, let's say it's like this, as an example, then your answer would be here to here, because that's positive, yeah? And then from the last point out. Now actually, the reason I picked this question is because I've already drawn the graph as an example. The graph, I did this, I think this was my first example, or second example. I have the graph here already. Yeah. So if I said, when is x positive? Well, is it positive over here? No. It begins becoming positive here. For this value of x, your graph becomes positive. And it's still positive, still positive, still positive, still positive. It's always positive. So after this point, your cubic is always positive. What is this point here? It's -1. So my answer to this question from the graph is x greater than or equal to -1. Yeah. It's from this point, this -1 point. Yeah? That's when it becomes positive. So, anyways, what I'm saying is, if you ever see a question like this, it actually is the same as what we've done this morning. You just have to use your graph at the end to figure out which part of the graph is positive and negative. Yeah? Yeah, that's what I was just thinking. How would the answer be a little bit different if the question was instead just a bigger than 0? How would my answer be different?
We're sort of negative part of it. Like the first half of the
Yeah? No.
X greater than -1 except 2.
Very good. Well, no, this isn't actually a 2 here. It's a 9/7.
Oh.
Yeah. No, but you got the idea. -1 to infinity, except except 9/7, and except -1. Yeah. So you would say x bigger than -1 and x not equal to 9/7. Because at those 2 points it's actually equal to 0, and we want it to not be 0, we want it to be bigger than 0. So it's still the same answer, but you'd have to cut out this guy and this guy, because we want it to be, if it was instead more than 0, we want it to be more than, not equal to 0. Okay. In the exam, this is the most common graph question. There's 2 common graph questions. Like 90% of graph questions. No, let's see. I'd say 75% of graph questions in the exam are cubics. They ask you to graph a cubic. Okay. So if there was a graph question, this is the best for what they'll ask you to do on graph paper. Yeah. Okay. So we can try these for 10 minutes. The usual story here. We'll do the first and the last one, please. Okay. In question 1 and 2. Yeah. Question? I'll come over. Yeah. Yeah. On the quadratic. It's quadratic or the cubic one? Oh. And you got the solution? What solution? How much did I get here? Not this. Yeah. I was seeing the one here, I think. Can I go back and see your work? I'm going to type it in first, okay? -b, that's 2. plus or minus square root of b squared minus 4 times a times c all over 2a. Yeah, so minus 2 squared. Four, yeah. But you can't do that. You're not allowed to do that. You can't take minus without square roots. It's forbidden. So there's nothing here to do. There's no calculation to calculate there.